Hello dear students, my name is Shashank, Master Teacher of Mathematics at Vedantu. Here we are presenting solutions for KVPY 2018 essay stream, that is class 11. In this video I have taken question from part 2, question number 65. Let's see what the question is. Suppose ABCD is a trapezium whose sides and height are integers. Means every side, all the four sides are integers, height is also integer, distance between the parallel sides. And AB is parallel to CD, AB and CD are parallel. If the area of the entire trapezium ABCD is 12 and the sides are distinct, all the sides are different, then the value of difference of positive difference of AB and CD means the bigger the difference between the two parallel sides AB and CD. It must be okay. The option given is 2, is 4, is 8, cannot be determined from the data. So let's see how can we solve this. However, the question is a very good question, good level problem. But I have tried it to make it simple for you. Let's see. Yeah. So first of all, considering the trapezium. Okay. Right. Okay. So I'm making the trapezium. Okay. So A, B, C, D. A, B and C, D are parallel. This is height h. The same h here. And suppose these lengths are, okay, I'm taking this as x, this part only, I mean this part y, this part as P, Q, R, S. So in the question it is given that P, Q, R and I mean let it be completely W, comma H. These all are integers, belongs to I plus in fact, right? So we need to find in this case the area is area of the trapezium given as area is equal to 12. Total area is equal to 12. So first of all, I have considered this entire area as the sum of these three figures, this triangle, this rectangle and this third triangle. Maybe some triangle is not formed, the trapezium is just a rectangle or combination of a triangle and rectangle, or it is the combination of a rectangle and the two triangles. But obviously as all the side lengths are different, definitely none of P, Q, R, W are same, no two are same. So in that regard we can say that P and R are different. So I'm assuming the bigger is R, I mean letting R is more than P. And yeah, however it's not sure that here that X and Y are also integer. X is taken as this part, Y is taken as this part, but we can prove in fact that X and Y will also be an integer. See, this S is nothing but Q, the same as Q, no? Okay, so definitely X plus Y plus Q is an integer because all sides are integers. And as q is integer, so x plus y is also an integer, right? So I'm going to prove that here these two parts x and y are must also be integer because h is given integer. So in this right angle triangle A, I'm taking okay this as m, this as n, suppose. So in the triangle DAM, h is integer, r is integer, this is a right angle triangle. Y, I am going to prove that y must also be an integer. See, here x plus y is an integer, and x square, that is p square minus h square is also an integer. Y square, which is okay r square minus h square, is also an integer because p and h are integer, r and h are integer, p, q, r, h all are integer, p, r, h all are integers. So x, we are not sure about x and y, but we are sure about x square and y square, that those must be integers. So we can prove here that individually x and y will be integer. First we'll have to prove that. So from here, if we take the difference x square minus y square, or better take y square minus x square, because I have taken okay y more than x, because r more than p, correspondingly y will be more than x. So y square minus x square, if I write y square minus x square must be a positive integer. So from here, if I write y plus x into y minus x is an integer, and here as x plus y is integer, so y minus x must be, the ratio of two integers must be rational. What do you say? Because integer upon integer, no, y plus x is an integer from 1, using 1. So finally y plus x is an integer from 1, and y minus x is a rational number. So from here we can say that if we add the two, subtract the two, x and y must be rational. But as we know here that x square is an integer, x is rational and x square is integer, means that x must not be non-integral rational number. Suppose x is rational but not integer, then x square will also be rational but not integer, but x square here is integer. So finally we show that but x square, y square are integers, means here I should write, I'm taking this as number 2, adding and subtracting 1 and 2, we got xy as rational, but x square and y square as integers. So finally we got means suppose x is rational but not integer, then x square will also be rational but not integer, but x square is given integer, so it contradicts our assumption that x is rational but not integer. So finally x has to be integer, similarly y has to be integer. So coming to the next page, this implies x and y must be integer, okay, rational and integer in fact. So finally coming back to the picture, here x is integer, so this triangle is triangle DAM, triangle CNB are the triangles, right angle triangles, in which all the sides are integers. Now coming to the Pythagorean triplets, definitely R, H, Y will represent Pythagorean triplets. I mean the smallest area total given is 12, So as it is a small figure, 12 must represent area of, right, the triangle DAM plus area of triangle DCMN plus area of rectangle DCMN plus area of CNB. So I am taking the same picture in this page also. Okay. So this was, I think, PQR. So we first proved that these x and y are integers. Y, x, am I right? Yes. And h, q. H, this is also h. This is q part from here to here. And right. So first of all, total area is area of okay, ABCD is equal to 12 now. So definitely this is, suppose this were taken as MN. Okay, MN. Area of triangle AMD plus area of rectangle MNCD plus area of triangle if NBC, if it is formed, is equal to 12. Now what areas of these figures are, we need to think, because all the sides of all these figures are integers now, because x is also integer, y is also integer. Area of this triangle is higher than area of this triangle, right? I'm thinking over the Pythagorean triplets. The smallest area in case of any Pythagorean triplet means a right angle triangle, sides of a right angle triangle with integral sides, with all the sides as integers. The minimum smallest dimension Pythagorean triplet is the triangle whose sides are 3, 4, 5. The area of smallest Pythagorean triangle is equal to Pythagorean triangle is is a triangle with sides having side length as 3, 4, 5 is equal to 1 by 2 into 3 into 4, that is 6. So the minimum area of the triangle NBC can be 6 here, and as the area of triangle AMD is higher than the area of triangle NBC in this case, because y was greater, r was taken to be higher than p, r and p were different. The question it is given that all the sides are different. So I discussed everything here in the first page. So definitely if area of triangle, which is a Pythagorean triplet, if possible, NBC is 6, then area of triangle AMD will be more than 6, which is not possible because then area of ABCD will be more than 12, which is impossible. So finally, so clearly here the triangle should not be formed. This triangle should not be formed. this triangle must have area 0, means, so from it's very clear that x has to be 0, right? And p equal to h, right? And then also, as the area of AMD is higher than 0, means area of triangle AMD would be 6, and area of, then area left is 6 only, this is 6, then this has to be 6. Area of MNCD is also 6. So now area of AMD is 6, means either H is 3, Y is 4, or H is 4, Y is 3. But in this case, but in the second case, when H is 4, H into Q is 6, then Q is 6 by 4, that is 3 by 2 is not an integer. So this case is rejected. This is acceptable. This case is rejected. Second case. So finally, we are getting the height as h, and the difference between AB and CD, which is in fact y only, is equal to 4 units. Acha, okay, height was not 4, it was 3, and 4 was rejected now. H equal to 4 was not possible, H equal to 3 was possible, and y is 4. Final answer to this question must be 4. So question was a little bit of analysis, higher analysis was there, but by considering the various part of the complete area of the trapezium and using the idea of Pythagorean triplet, the smallest Pythagorean triplet is 3, 4, 5 side length, having side length 3, 4, 5, and its area is 6. Areas, the entire picture was given as 12, so it was not tough to analyze the picture, the situation that one of the triangle here would be 0. I mean, no triangle would be from the right one side of the trapezium, and finally we got the difference, the required answer as 4. So coming to the options, so the entire picture, entire solution, first we need it was needed to prove that x and y are integers, and that we could do, we could prove using these ideas I have right explained here. And after that, it was not easy to get the various lengths of the entire picture, the trapezium. So final answer is 4. The difference between the parallel sides is 4. I hope you understood this solution and you enjoyed it. Thank you. Stay tuned for the next question.